it's worthwhile in order to at least engage into a discussion behind this. This is the fourth and last entry in Open Ed Week's series for ADAPT. It's also our last presentation for Open Ed Week as a whole. So once this is over, it's party time for me. And what we did, just as a rehash for this, and the videos are already on our YouTube channel. The first day on Monday, I talked about a general introduction to ADAPT, what ADAPT is supposed to be doing, where we're going with it, and such. Number two, Tuesday, the second in the series, focused on building courses in ADAPT. The third in the series was yesterday, focusing on building assignments, and at the end, adding questions into the assignment, although that was a little rushed. And today we're talking about why ADAPT is called ADAPT, and that's because of the adaptive learning infrastructure behind it, and specifically the learning trees, which is how we pursued doing that when we actually built ADAPT starting 5 years ago, thanks to the state of California's investment. Yeah. So let me move on here. As a reminder, there are two types of questions in general, or two types of homework that's given out in classes. One is formative and one is summative. And the technical description for that is that summative is meant in order to evaluate or to assess the student's knowledge or performance. So it's intrinsically an assessment infrastructure. Formative is meant in order to be able to provide feedback to the students uh, in order for them to learn from the assessment. And many of the times through our class, we try to blend the two together. So obviously in a final exam, that's a summative assessment. Students may learn from it, but we don't use that as part of the criteria for success in the class. The homework that we do in the during the class is oftentimes summative in the sense that it's meant in order to assess if the student's able to do something or not, and for them to then pursue or at least build upon the skills necessary to be successful in those questions. And many times people like to separate out formative assessment in terms of summative is where you want to keep track of the student's scores. So this student did this performance on this specific score, while formative is uncoupled from the grade book. So it's more practice, more learning, more training off of that. However, many instructors oftentimes like to argue that even summative questions should be a learning experience for students in order to obviously move forward in the class. So the question that I would have here is, what makes a formative question useful? What property of a question makes it a useful, most of it makes it useful for students in order to be, to learn from? And this is my question to you guys. You can either talk verbally or type it into the chat, but I want to actually make sure that we reinforce this idea um, as a groundwork for talking about the trees. Anyone have any idea?
Well, I tend to use just assessment. So in a chapter kind of problems
You
like that.
do,
Yeah. Yeah.
but
Review and chapter work. Yeah.
yeah. So let me argue this.
Concepts. Yeah.
So you have assessment, and you probably are doing assessment, but most of the time, I presume that you give solutions out to your students.
Correct.
Okay. So at the point that you give solutions out to the students, you're giving them the opportunity in order to get feedback and to learn from the actual procedure. So at that point, you are not just trying to assess whether they know it or not, because I don't give out these solutions to the final exam. It's not necessary because it's meant just to assess. But during the class, when it's actually evolving, you care for using this as an assessment in order for them to actually do the work, but also to give them feedback in order for them to learn from what they've done. And I think that's
Correct.
probably true for most, if not all of us in this room, because we want this to be an educational experience for students. So that feedback is important. So the conventional way that we like to view this is, here's a question, point after the question is over that they are able to submit. And that is a key component of how you can use traditional questions in Adapt that you can basically say, here is a question. The question the student submits after the deadline is over, then the scores are released and the solutions are released with it so that the students can actually learn from that. Rachel added into the chat, formative assessments are part of the learning process, so it should be opportunities for students to revise and revisit their work. Be great in order to revise and revisit. I certainly would argue revisit is a critical component for doing so. Revising is one mechanism to facilitate it, but not necessary in order for the students to learn. Uh, so why do I actually go about doing this? Well, the idea behind learning is the key point behind this application of assessments or this application of homework. And it's convenient or it's powerful in order to provide feedback as we move, but we want to be able to provide or scale it out a little bit more. So just as a rehash, like I said previously, the structure that we have in Adapt is we have courses have assignments have questions. And that's a conventional way in which we go about doing that. We release scores and assignments when we want, whether automatically or manual after deadlines. And hopefully students are able to learn from that system. Adapt does have a system in place in order to identify and keep track of students reviewing questions. That's basically looking at the questions and the solutions after the deadline in order to identify if they're using the homework and the questions as a learning study guide instead of just basically as assessment on their own. We also track time on task in order to see how much time do students spend on the question before the deadline. It's basically the same evaluation metric. It's just whether it's before the deadline or after the deadline. And what we find when we do this is the vast majority of students don't revisit the homework afterwards. And I find that very confusing, uh, uh, except for maybe a few days or a day before the exam. And even that, they don't do it quite as much as other resources that are out there. So this conventional approach has less utility than what I think it could have with this appropriate effort in order to be a learning experience for students in order to be able to gain here. And that introduces the concept of not just giving out an individual question, um, but to give out something a little bit more sophisticated. And sorry, I'm looking for the right page. Um, so I'll just go to here. So we introduced the concept of adaptive learning feedback. So if you're unfamiliar with that term, the idea behind it is that the interactions between the learning platform, in this case here, Adapt, and the student adapts to the nature of the student, adapts to what the student knows, adapts to how the student interacts with it, such it's actually to be more efficient in terms of getting the information to the students that the student doesn't know. Uh, and that right there has a lot of potential. Uh, and that effort has been around for several years, several decades, in fact, but really started to get popular in the early teens. And now that we're switching over to more AI-based infrastructures, it is massively popular within that approach. Now, I'm going to reserve my judgment in terms of what AI is able to do and not able to do in here, and just focus on how we go about addressing this. So again, the point of adaptive learning is to build an infrastructure that will uh, provide a different experience and an optimal experience for different students as they go through the process and learn from what they're doing. So learning trees are not meant to be necessarily useful as a terminal summative question, like on a final exam. They're meant to be more formative in order to guide education. Yeah. The other term that's oftentimes thrown out there in terms of the adaptive learning literature is the idea. Am I recording this? I am recording this. Okay, sorry. Is the idea that we can use electronics in order to act as a tutor? Because ultimately, a tutor comes in, if you were to hire a traditional tutor to help you out, and they are able to identify deficiencies in the student and then help to fill in those deficiencies in order to be that. So they are adaptive learning. And you're paying for that. You're paying for the experience, you're paying for the knowledge for them to come in order to guide them in certain directions. And in some cases, spending a lot of money for that. I think in some cases actually more than what faculty get paid in our respective classes. But that's a different topic. What we are trying to do, and many other people, is to build an infrastructure in order to provide the same capabilities with computers, using algorithms, using models, using profiling, and using lots of other stuff that's involved in that. Um, so we can refer to it as a virtual tutor, which is the term that's used in the community for arguing being able to take the place of that. So instead of having just a single question and a solution, ideally a well fleshed out solution, which we go through a lot of effort in order to do, you want to be able to have something that comes in and helps the students in order to identify what they did right and what they did wrong in order to fill it in and move it down. Now, I apologize for a very slow introduction to the idea behind adaptive learning, but it's important in order to set the stage for the conversation about why we do what we do and why what we do or the specific tack that we took is actually a successful tack off of doing that. So and I apologize for not having slides in order to be able to describe this. So I'm using this in a more verbal way. There are two ranges or two different types or ends of a spectrum of adaptive learning. Yeah. So on one end is the uber computational algorithmic based profiling infrastructure that comes in and identifies things within frameworks and puts things into a structure and identifies that this student likely knows this and doesn't likely know this, and then it uses that in order to be able to give students questions in order to be able to advance. The one successful platform that does that well would be Alex, which was originally a math-based platform in the University of California, Irvine, has expanded into other fields with similar capabilities, although I think with a more limited efficacy than what they did with math. And that's now, I think, owned by Pearson. So it's a for-profit access, and I think it's something like $80 or $90 or something like that per student per term to access Alex. So it's big business. Um, the other end of that is something very simple, and that's what we chose to do. And while it's simple, it has a lot of benefits for it, and that's what we refer to as learning trees or decision trees. And the idea beside the decision tree is that you make a flow chart as students evolve on the flow chart in order to address certain topics necessary to master for the system. One can envision this as how, at least in a static version, this is how scaffolding happens. You come in and you say, okay, in order to master this, you need to know this. In order to master this, you need to know this, and you kind of guide them along that direction. But what makes this adaptive, so that different students can interact in a different way, is that we set it up so the students are the ones that dictate how they want to evolve on the tree. So they can decide if they feel that something is important or they mastered it, they can skip over certain things and move forward behind that. And that approach in many ways is superior to the uber calculation based approach, especially now augmented with AI, uh, because it gives students agency. So they're engaged in their educational process. They're not spoon fed what they need to do next step, next step, next step. And I care about building robust students. I care about students actually being able to feel confident in what they know and what they don't know, and to be engaged in their educational experience, because typically when students are more engaged in their educational experience, the more likely they're going to be learning from it. Um, the other aspect that I'd like to push is metacognition. So metacognition is a particularly difficult concept in order to teach to people, teach to students, having students being able to identify what they know and what they don't know, or perhaps to know the unknowns and the unknowns, to use Rumsfeld's quote back 22 years ago. And teaching metacognition, and I think, is exceedingly important in order to be able to identify how you're going to be moving forward in your development. Because if you don't have a good understanding of where you're at, you have a hard time understanding how you can grow from that. And these algorithmic based systems don't do that. They spoon feed our students. Our students become weak when they leave. And I think that that's a really negative thing for the way we go about doing so. The last thing that is why we address this sort of decision tree based system is that it is it's financially quite much greater return on investment. You don't have to take as much money in order to build learning trees as it does to build an AI-based algorithm infrastructure, which sometimes works and sometimes doesn't work, and has limited utility. And if it's easy in order to construct, it provides the opportunity for more people to come in and build more of these learning trees, and move it forward. Now, I'm aware for the last 7 to 8 minutes or so, I didn't have any graphical description in order to talk about what I'm doing. And I hope that you guys are on board with the sort of description that I did here, so we can actually use this in order to talk about how learning trees are set. Is that a fair statement, or did I confuse you a little bit by not having presentations or having slides there? Rachel has a thumbs up. Ron is also a thumbs up. And Mark is the last one. I'm going to
Oh,
assume that
yeah,
he's
yeah,
also.
I'm fine.
Okay.
Where's the
Okay.
sound?
Yeah, like I said, it's important in order to emphasize why we do what we do and where it fits into the big system, instead of getting stuck into the nitty-gritty technical details. I love the technical details, but the technical details have to result in an end product that we want. So let's go into these things. I'm going to go to adapt. Everyone in here, I think, has an adapt account. I'm gonna log in here, and I'm logging in with my UC Davis account, which is actually the right account for me here. Uh, Now, the idea behind what we were doing, and I'll just show my general chemistry for majors class. I think I may have shown this earlier on. I'm not releasing any FERPA related material because I'm not going to any student performance off here. I just want to show what the assignments are. So these are the assignments that I have. I have lecture assignments due every day. I have my labs, both pre-labs and post-labs, that they submit. I have weekly homework, which consists of about 10 to 12 or so problems to solve. I then have my midterms, and then I have practice homework. I have hundreds and hundreds of questions of practice for students to be able to parse through. And it's entirely up to them in order to decide if they want to go about doing so. Again, that's part of my formative desire. I have practice exam problems. Let me phrase that. Practice exams, which of course have problems on it. I have discussions because we have a recitation section in my class where my TAs will run that. And then I have assignments that focus on learning trees. And I could tell that because they have little trees here, and it gives you a very Christmassy feeling as you do here. And the idea behind here is that each of these assignments with learning trees may have multiple learning trees. So this has 5 learning trees into it. I sometimes liken an assignment with learning trees as an orchard of trees, but I don't push it too hard in the branding. And the idea behind here is, if this were a conventional assignment question infrastructure, is there'd be 5 questions and that's it. And the students then can get the feedback after a certain time, and that's their only learning experience outside of being able to ask for assistance from their TAs or from their instructor. But the learning trees are more complicated. And they provide greater information off of here. And the idea is, instead of a single question that comes up, so this is what the question looks like for the student, or at least this is the instructor view of that question. And it gives you a single question. If I am a student and I get this question right, that's fine. Then I go on to the next question. I don't need to know all the details associated with how to actually master the components of this question to be successful. Uh, and that's part of the efficiency aspect that adaptive learning provides. So instead of saying that everybody needs to learn every concept, you can let them deal with which ones they actually do. So like this question right here, which is just a very simple significant figure question here. And I have about uh, 54 students that got full score off of here, and few of them did not get full score. Which probably means they didn't try as much as I wanted. Oh, actually got six points. They missed 1 or 2. Anyways, let's say that I am a student and I get these questions wrong. Um, this works well when you have complicated questions, but it can also work fine with simpler questions if you want. And the idea is, as a student, I can then get a do-over in order to be able to do the question again. Um, So in other words, this is typically done with a single submission option that they pop in, and then that's it. If I then want to earn my do-over as a student, I can click the learning tree, and now I get exposed to the learning tree. So this is where the complexity happens, in that instead of giving a single question to the student, I give a question with backup nodes that are of particular importance. The nodes that are red are the ones that are exposition. So they're ones meant in order to instruct. Uh, they could be video, they could be text, they can be interactives, whatever it means, different mechanisms for students to learn from here. The ones that are blue are assessments. So those ones are auto-graded assessments. And the idea behind here, in principle, is that you have a question up here. The question involves understanding multiple skills to do this. I'm going to channel my inner chemist and give the example I oftentimes give in the third quarter of general chemistry. Let's say I'm talking about the Nernst equation, and I have a Nernst equation issue. For those of you who are not familiar with it, this is calculating the change in Gibbs energy for a actually, no, this is calculating the cell potential under non-standard conditions, using the cell potential under standard conditions and what's called the reaction quotient. And it requires understanding a handful of different things for doing, like understanding balancing equation, understanding calculating a cell potential under standard conditions, understanding how many electrons flow in that reaction, understanding how to make a reaction quotient, how to do a logarithm of that, and then bring it all together in order to be able to do this. So it has like 5 different things that are necessary to master that specific type of question. Uh, and invariably, students come in and they make a mistake. They don't understand one or two very well, and they're a little bit soft off of it. This right here is a simple question. I should create this Nernst equation so you can actually see it instead of giving you a concept behind it. So I have this auto-graded question. This is the same auto-graded question the student had when they looked at it above. Then I go in and they can then take a look at an exposition node. This right here is just saying, look, you didn't get it right, the root question. You need to understand these 2 skills. You need to understand the definition of significant figures. You need to understand when zeros are significant or not. Then they say, okay, there are 3 branches in this trees, and this kind of gives a foreshadowing, saying that the first branch deals with defining significant figures. It has a text-based exposition. The second one deals significant figures, but it has a video-based description. And the last one are just practice problems, so that you might not learn from exposition, but you'll learn from actually solving the problems. Some people prefer that. The intent off of here is that you can decide how the branches are. If they could be all 5 of those different skills that are on the Nernst equation. They could be 7 different skills where you talk about things in different ways. So a student can decide they want the text or the video or some other approach for doing so. I'm going to exit this node, and now I make a decision. Which one do I want? Well, I can go in here and deal with some text. This is relatively straightforward, just saying here are the rules for text. It's a more focused approach for doing, just like what a tutor would do, saying, look, you don't know this, let's deal with that right here, just in a very targeted fashion. So you go over these things and you identify that, yes, from this, I learned something. And then I get an assessment as a student to say, did I demonstrate proficiency of that? So I look at this number and say, did I identify all the significant figures that are on here? So if I came up here and I said that there happens to be 5 significant figures, I could submit it. It doesn't give me the answer, I think, because I'm not I'm not a student taking it in a class. But if I go through it and I get the right answer, then each time I go through here, these nodes turns from their color to, I think, green. And that represents that I have successfully completed these nodes, either by handling the assessment or spending a certain period of time on the exposition. I'm kind of throwing a few things together off of here, and it'll make more sense when I actually switch to a student view off of here. The intent off of here is to ask, what do you think a student needs to do to be successful in a learning tree? Well, the number one criterion to be successful in the learning tree is they need to be engaged with it. So they don't just sit here and then just go to the end and then just get their do-over and submit to the root question again. And that's why we have this exposition set up in order to give some exposition and then evaluate if the student has learned it. You can build these trees with as many branches as you want and as many expositions down below or as many assessments that you want. For example, if you think it takes multiple videos to address a specific concept, you can add them together into a row. The key point for the student's perspective is that they earn a do-over if they get if they go through every node from the top to the bottom. It could be in this direction, it could be straight down, it could be all the way over in this direction. It doesn't matter. The students have the agency to decide what they want to do. I, as an instructor, can actually decide how many branches are necessary to be successful. How many branches do you need in order to earn the do-over? Like if I feel that they need to have more than one, but they need to do 2 or 3 branches, assuming I have a lot more than 3 branches, I can then put that down as a requirement. And that's basically saying I want a higher standard of engagement with the tree for my material. So in other words, I want them to learn more. That is the essence behind a learning tree. It's choose your own adventure story. The students get to guide where they want to go. They can come in and say, "Oh, um, I already know," or let's say, "I already know the definition of significant digits, but I have problems identifying whether zeros are significant or not." So they can just go down that path, or they can go down this path. Moreover, if I went to the Nernst example, I can come in and I can add an exposition or a branch dealing with logarithms, right? No one likes logarithms. Students especially don't like logarithms now, and they also don't have a proficiency in order to be able to handle logarithms on average from their high school. So we need, I think, in order to add branches into our trees that deals with basic math, whether it's algebra or whether it's pre-calculus, that they need to go in and get a refresher. And you can say, well, look, you got this wrong. Did you get it wrong because you don't understand properties of logarithms? Here's a refresher on that. So you can be more expansive in what the scope is of this virtual tutor, even though really the student is tutoring themselves using this tool in order to be able to advance this. Again, this right here is far less sophisticated than a adaptive learning algorithmic based system based off of Bayesian statistics and thrown in with some AI and other stuff off of there. But it could be formulated in any different question, in any types of question, any type of field, as long as you have an idea about how to cut questions up into the constituent components. The problem that we have here is while it's much easier than these full-blown computational adaptive learning systems, it does require a bit of thinking in order to create these learning trees. And this was one learning tree. This was created from San Bernardino, Cal State University San Bernardino, I believe, for use in their class. But if I want to do this for a wide range of different questions in my general chemistry class, I need to go through and really build these things and flesh them out, both with solutions and answers and things like that. And I don't need to have them all mastered before I use the tree, but I need enough in order for the students in order to be able to address. Are you guys cool with that concept before we actually start transitioning on into using the learning tree? Because I really like the learning trees. I think they're really powerful. I don't just think, there's lots of data to argue that they're really powerful. And for those education people in here that care about assessments and such, it provides you with the opportunity. Hold on a second, Mohammed. It provides you with the opportunity in order to get a pre and post. Basically, you can demonstrate that students learn from learning trees because you can identify what the students learn and know up here. Then they go in the learning trees for a period of time and they get that same question or maybe algorithmically changed numbers up at the top. And then we get a pre and post in order to evaluate that. We're not actually looking at performance. We're truly looking at learning using the formal definition of learning, saying that you know where they were and where they're at. And students learn from learning trees. Our issue is to flesh out as many good detailed learning trees such that you can actually have lots of them in your questions so they could take the place of conventional homework that's out there. And we were transitioning toward that until a handful of months ago when the state pulled our grants because the state has serious financial issues. Anyways, Mohammed has his hand up.
that that I noticed problem in this one from my point of view was the first question. The first question is not one question, and I now notice that you have multiple questions to cover all the branches. This is good for mathematical type of questions where this is like significant figures or the equation you are talking about. If we apply it to some more advanced things like organic chemistry, say spectroscopy or reaction mechanisms, then one question does not allow me to put multiple questions within one. So that is something probably I think I have mentioned to you before is needed that there should be possibility to put multiple type of
Yeah,
question
yeah,
within one
yeah, yeah.
as boxes.
That right there is just the nature of the question, whether you use the new organic chemistry technology. Um, by the way, I just heard back from Herman about some more advances that were just introduced into it, like arrow pushing and such. So you should be happy once I actually implement it directly to adapt. That right there is a different story. So that's just basically what's the technology of the question itself here. Uh, it's not an issue about how you add questions together with different expositions into a tree. No, but typically most questions involve some capacity for scaffolding. And if you have the ability to scaffold, you have the ability to build learning trees around that scaffolding, saying you need to know this, you need to know this, you need to know this. And then there you go. So the key point is that you let students take the rein, take the control of the wheel, and decide how they want to evolve on the tree. And that forces them to think about what they know and what they don't know, and what's the best use of their time. Uh, and that right there intrinsically improves the efficiency of what you're doing here. So you are not stuck forcing students to go through things that may not be important for that individual student. Because the students are not going to sit there and want to sit through something annoying. And if they sit through something annoying, let me phrase it, sit through something that they already know, they don't learn what they need or to improve. They don't learn at all when they're down here because they've already gone over things that they learned. So they may not, most likely won't be successful when they get their do-over again. So they'll choose the things that they need in order to be able to move forward. So this you could think of as is a very strong feedback or very strong solution infrastructure such that students can actually learn a lot. But because it's a forced infrastructure, in other words, they get the opportunity in order to get the do-over, they engage with it more, and then from that they will have a greater learning. Like I said, these sort of decision tree based approaches are typically considered to be successful than individual question based approaches, uh, uh, giving you a significantly better return on investment than what you get for algorithmic based things, which requires a different level of sophistication. And we still have a desire to perhaps introduce that additional technology into our platform, but it requires lots of other things like aligning questions to frameworks and implementing more advanced analytics and other things like that. And that's not on our immediate radar, even though it was when we still had the Department of the California Education Learning Lab grant. So, anyways, uh, so that's the approach that we have here. Let's take a look at this from a student side. So here's a question. I'm a student. I have 11 days to do this. This is because I have 11 days until the quarter's over. And such. So here's the question, and I'm just going to randomly pick these questions, which I'm sure I'm going to get wrong. And I complete the submission, and unfortunately, I didn't answer the question right. So I didn't get full point off of here. I can go into the learning tree and complete one path in order to reset. It should be to get a do-over, not a reset. And now I'll go into the tree and everything is red. I can click on here. And now I read over this thing. I'm supposed to be on it here for, I typically give 60 seconds or something like that. But for the sake of this conversation or presentation, I'd make it only 5 seconds. And then I've been successful and now is green. Okay. I can't skip over. I can't go straight down here. I need to go through these things and say, okay, this is a video, uh, and it brings this in, and I can say, okay, I need to watch this video, uh, and over for a period of time, which is typically 60 seconds or something like that. And we can start at different times of the video. I can sit through a full 6 minutes of it if I want, but we don't force people to go about doing that. We could do something like that, but we're trying to be gentle in the way we do these things. So I've successfully completed this question. It should be exposition. Oh, isn't. I killed the whole tree. Yeah. So that turned green. So now I come in here and I have to assess that specific task or that specific thing, which is identifying if zeros are set up. So this right here is technically isn't captive, leading, or trailing. I'm not entirely sure I know what captive means in this context, to be honest.
Between significant numbers or figure.
Oh, is that what it is? Oh, is that how you do it? Okay. I hate significant digits anyways. I like errors and propagation of errors to describe these things. Okay, so you have this thing. So this is a trailing. These are, I guess, leading. This right here is captive. This right here is tailing. This is, I guess, leading. And I've done it all right. Thank you, Mark, for helping me with my introductory chemistry. So I have gotten this correct. I've earned a reset, and now I can restart this and I can solve this problem again. And the idea is that now I have the ability in order to go through and solve it. If I get through it and I submit it again and I'm wrong, I can go into the tree again. And it can continually bouncing back and forth between the tree in order to be able to do that. And the ideal way is that if this is set up, is that the tree, the root question at the tree here will change the numbers a bit because it's algorithmic if written together, and provides an opportunity to test on the basic concepts of the root question, but not have them know exactly what the root question is from the previous thing. So in other words, it's not just more of a randomization, submitting numbers in order to be able to do that. So I can do this, I can earn do-overs 3 times because there are 3 branches in the tree, and such. There are other topologies that we can do in order to make this thing work rather than doing this sort of approach for doing it. And we looked at other topologies and some of them are actually quite valid, look like they have quite interest level. This is just how we have formulated it in this way. But one can envision different paths, like always being able to go through a series of scaffolds and then bounce off at every scaffold in order to get assistance in order to deal with those sort of things. And we may be interested in order to be able to pursue something like that. The key point is we wanted something that had clear criterion for success if the student has it put in place. So, Ron, you have a bit of text there. Do you think you want to say it verbally, or should I read it out loud?
I can talk. No, I was just
Okay.
wondering with the root question. I can imagine, depending on what the question is, how complicated they are, they might not know what they're weak on. So,
Yeah.
is there a way to identify that for the students? Say you should really do branches 1, 2, and 4, or something like that.
Oh, yeah. So to do that requires profiling, right? You need to identify what the students have done in the past and then say, yes, the student most likely has a problem with this skill or that skill. And we don't have profiling embedded into the system, but in principle, we can collect the information for that. So if you, for that to work, you need to have previous performance, right? Because you need to have some idea in order to identify what the students know and don't know. And then from previous performance, you have to have every question tracked to a specific learning objective. That means you need to make sure the questions are set up like that. And most of our questions are not set up like that because it takes a bit of time for aligning questions to those things. And then you're able to implement that says, yes, the student has an 80% probability of mastering this type of question, or a 20% failure rate. So the way Bayesian statistics works is kind of funky. But you need data for that. And this is one of the problems that you get with these adaptive learning engines that that try to build profiles, is it needs lots of data to build profiles. So what that means is you need students to do lots of homework problems. And that sometimes works against you because while you may have in math lots of small little problems that you can evaluate if they actually learn things. But in chemistry and more advanced topics, I don't want to say more advanced, but topics that that require a lot more sophistication in order to be able to implement, we're not going to give them 100 problems in order to be able to do so we can build good profiling. So in the absence of that information, we rely on the students in order to build their metacognition skills to identify what's going on. We might be able to do stuff with the limited amount of questions that you have that they've interacted with it, but it's going to have a hefty uncertainty associated with it. But what we can do is not necessarily target this individually for each student, but to build statistics and say, well, look, 80% of the students in the class are going down this direction. So we can tell the students, we think that 80% of the students in the class feel that this is what they need working. And that might be some guidance in order to dictate them what they do. But the key point from a metacognition skill is for them to actually develop that skill and not be told what they know and what they don't know. I understand that that may not be the entire goal of what you want to do. It's not the entire goal of what I want in my class, but it is a critical component in education that I think that we do in typically a very poor job with. And I mean collectively in academia, including myself. So
Can I ask a follow-up then?
yeah, please.
So on the initial root question, presumably you set up those 4 or 5 questions that you have there to specifically test for the things on the branches, right?
Yeah.
And so
I
could
typically
you
formulate it the other way. It's like I know the questions that I use in my class, and then I go in and I say, what are the skills necessary to be successful? I don't do it the other way around, but you could.
Yeah, so I was just thinking that if you did it that way, so if you set up the root question to specifically correspond to the branches, then you could actually tell the students, well, we really think, based on the fact that you missed 1, 3, and 5 here, that means you really are weak on X, and you should really do branch
Yeah. Okay.
2.
Yeah. So that's an excellent point. So basically, you're talking about you're getting the profiling from the performance and the root question, not from past questions. Yeah, I see where you're going there. Yeah, you could do that. That's pretty straightforward. So you get the feedback. I mean, DAP knows which questions are wrong. So if you know which questions address to each of the branch, and that you have a situation set up that you're able to test different parts of the branches inside the question, you can go about doing that. Like in the Nernst equation example I give there, I can't envision ways in order to be able to parse it out in that way. But in some cases, I can see that as actually being beneficial in order to be able to put that together. That's a good question. That's a good idea in order to be able to do that. If you put the thinking down and the nature of the question, we'll set it up for you. But you could do the same thing in terms of not just multiple questions, but a single question, and then you are able to identify the common misconceptions in answering. If it's just a number-based question, you can say, well, they have a negative sign on here. Like when I'm introducing work, and students have negative sign or positive sign or heat, and they just don't have that right. So I give them half points. But if I have it in a tree, I can start to talk about, well, do you know about the sign of work and heat for chemists, which is obviously going to be different than if it were physicists, because they have different signatures. Of course, the chemists are correct and the physics are incorrect. That's a joke, by the way. But anyways, you can get the information perhaps by the way that they actually responded in terms of identifying what their deficiencies are off of that. That requires a bit of sophistication, but you can go about doing that. One way in order to help do that is to look at the spectrum of answers that people have and identify that there are probably clusters associated with different fallacies or different deficiencies or mistakes in which how students addressed. And then from that, backtrack it out and say, this student's have a problem because of this. They submit in this branch. They have this subset of students have this general issue. Let's guide them into the different branch because of that. I like that a lot, but it does require a bit of thinking in terms of how to interpret the data that comes out. Yes, Mohammed.
Yes, just a little suggestion. The same thing that I pointed out before, instead of having one root question, why not have multiple root questions, and then each question related with one particular tree branch so that the student know, okay, if I don't solve this one, I should go to this branch and complete that learning and come back.
I'm not sure how different that is from having a assignment with multiple trees.
Not much different, but in the case of organic chemistry, for example, I cannot put Sketcher in multiple questions, multiple times in one question or something like
Yeah,
that.
that's just the status of the development of the sketcher. So we will be able to provide you everything that you'll be able to do in any question can be embedded into a tree. So when we give you the option in order to have multiple steps, or you're making a mechanism, or you want to do step one, push these arrows around, step two, do this or whatever else, that will be formulated. You could build a tree around it. And that's just a state of development for us. That's all.
Okay. So right now, maybe I do not know. Then let's say if I choose one type of question, say fill in the blanks or choose the best option, I cannot put the multiple choice within the same question. So that is again a separate block needed, or within one block, multiple type of questions needed to achieve this target.
Oh, no, you can do that. And certainly with web work and iMath AS, you can build complex questions that if you're
Okay,
talking about
only working in the
native, on the other hand, is using QTI. Basically, what your learning management system does is not designed for multiple questions, but in principle, it may not be too difficult. I need to talk to Eric about being able to do that. So you can say, here are 3 questions. Question 1 is multiple choice. Question 2 is number. Question 3 is radio buttons or something like that, multiple choice, whatever. Because I do that all the time in web work questions. So typically I ask, you do this, type the number in, and then I have a follow-up sort of concept. Is this exothermic or is this endothermic? And just kind of get them to think about interpreting the results that's out there. So if that's something that you feel that you need immediately, then submit a ticket, and then I'll put it into the queue. I don't think this would be that
no,
difficult, to be honest.
not immediate, but ultimately, if we can achieve it, because the native is much easier to handle and much easier to learn for developing purpose.
It is, because it's a graphical description, a graphical way to code instead of actually coding. That's fine. I think that's actually quite reasonable. Please submit a ticket so that doesn't get lost. Like I said, I can already see how to do it in my head, and I don't think it's that hard at all. In fact, I think Eric can probably put it together in a day or two without any issue.
Especially when I was doing the spectroscopy, I needed a 3, 4, 5, 6 question in a row, and then I have to split them rather than put them in one place.
Yeah.
I'm sorry, you said submit a ticket. What do you specifically mean
So
by that?
LibreTexts has a support ticket line. So if you go to support.libretext.org, or if you go to any here, there's a support button right here, and that's where you can submit a ticket, and it goes to our queue. I'm not sure why. Yeah. And you just submit it right there, and then we address it, and it doesn't get lost. I'm not saying that we're necessarily going to respond to it quickly, although we try, but it's a easier way in order to ensure that it doesn't get lost in the email deluge that we have, because we have
That can be specific practical questions.
It could be anything you want.
Oh.
Okay. So you want any feedback, if your students have access to it. So if they have an issue with a specific question or something like that, they can throw it in order to be able to do that. We tend to we try to address the students quickly, because first, it's part of their education. The second part, if it involves us having to update coding or something necessary in order to make it, that improves everybody, and we want to be able to do that and move it forward. In the far future or so, we might actually have to fold in customer support for students somehow into support for adapt. Like, for example, if we get successful in the RFP for the ZTC, that's going to be for the repository for OER in the California Community College system, that would be folded into it. So we actually have support for maintaining responses to students. So far, we haven't gotten very many. I mean, got a handful every week. That's not too big of a deal for us. But yeah, feel free to capitalize on it if you want, or you can go to support.libretext.org. That goes directly to this page. And you don't even need to have an account. You can come in as a guest and just submit it, which many people do. But yes, feel free to submit that ticket, Mohammed, so I'll make sure that we actually address it when we can.
Yeah,
Okay.
I will do that.
Looks like I logged out for some reason or another. I'm not sure why when it bounced around. So, okay. This was meant to be a discussion around building a learning tree. We have 5 to 10 minutes left. Do you want to transition into that, or do you feel that this is too much to do on a Friday evening or Friday afternoon?
Okay, so how long did it take you to put together for one homework set, a set of learning trees and with problems? I mean, just to give a ballpark idea.
Well, it depends if you're using existing trees or not. If you're using
Okay.
existing trees, it's just as easy as building a assignment with existing questions. So if you go under dashboard and you go to browse learning trees, you'll browse all the open learning trees, all the public learning trees, and you can come in and say, okay, I'm not going to tell you that every learning tree is perfect. Some of them require a bit more processing. So, for example, earlier today, Greg Allen was talking about uh, his experience. He's a faculty member in Mendocino College, and so here's a learning tree he's put together. It's relatively simple. It doesn't have to be overly complex to still get benefits for the students. So this is an ICE table KC. I actually just taught this today, just a few hours ago. So here it is. Here's an equilibrium constant. What an equilibrium constant all gases. Okay, so this is not even an ICE table. Yeah, this is not even an ICE table. I don't know why he has ICE table on it. So this is just basically looking at these things. This is using web work. I submit the answer, which is going to be wrong. And it doesn't tell me because it doesn't check it automatically there. And then I can come in and identify this thing. I don't see why he has ICE tables on there. Did I miss something? Oh, it's the initial concentration. I missed that word. Okay, so this is an ICE table and such. So then it has 2 questions. One is using an ICE table using square root and not the quadratic equation. And it's just a video in order to go through that. And here is also another video dealing with using ICE table. What's the description of here? He didn't write a description for it.
Well, how long do you think it took him to put together that learning tree?
Well, this is just these are just basically 2 examples of what he's doing.
But say he did that from scratch. What do you think?
Half hour to an hour. It depends upon. Oh, so this question probably already exists. So he didn't have to code this question. He just said he grabbed this question and he says, okay, I want to build an ICE table from that. And then you identify, well, what are the skills that they want? And then for these things, you can just go to the LibreTexts libraries and identify, well, where's some exposition dealing with ICE tables using quadratic equation? And there's going to be an example already put together if you want to do an example or some exposition, and you can copy it down there. So you can build this thing quite quickly, as long as you have an idea, as long as you're a subject matter expert to know what are the skills necessary to be successful up here. And what he's trying to show is the 5% assumption, so you don't have to do the quadratic equation. And if you want to using square root into quadratic, I guess using it if you're able to just simplify it. And I would have a third one in here that would say do the same thing but use the quadratic equation. And to be honest, since it's a majors class I teach, I'd have a 4th one that would have a cubic root and say, look, here's something more advanced. Go and do a numerical solution in order to get the answer off of there. So yeah, I mean, I would spend probably about an hour creating the tree in order to make this work. That's why it takes more time than individual root question, but it's far more rewarding. It has a much greater chance of teaching students what they're doing. And we have about 300 questions on here. Most of them are in general chemistry, but we want to expand massively on here. And we just haven't gotten around for doing it because we've been focusing on so many other things and such. And then once you build it, then everyone can benefit from it, right? So you can come in and say, okay, I want a different tree. and such. I encourage you, if you want to reach out to Greg Allen about that, he can certainly give you a lot more details to do it, since he teaches in your system and probably teaches a near identical class. He'll give you a much better idea than my class, which is going to be at a different level than what you guys teach. And it's just a Le Chatelier principle: shifting left, shifting right, and such, and such. Students say that they've liked this, and our data shows that they are learning from this. It just requires effort to build these trees. So we're at time. If you're willing to indulge me for a few minutes, I can just show you how to build the tree. There's also an instruction manual for it. Thank you, Mark. That's available. There will be a button up here in order to show you how to get to that. But it's relatively straightforward. So I'm going to go into my learning trees. So it's my repository. These are the trees that I have been playing around with. Rachel also leaves. So let me just complete this for the video for the two of you that are here. Feel free to leave if you want. And I just want to build a new tree. I can clone an existing tree if I want, but I'm going to build a new tree. And I just call this new tree. I have a public description that just basically tells people what this is. This is a special tree. And that's just make sure that you're part of the community and it describes what that tree is. Because again, this is something different between an assignment and a question. This is an assignment, or this is a combination of questions in an organization that then operates like an individual question and assignment. So sort of something in between the two. Private notes, if I want some annotation connected to it, or I can make it public or private, I'm going to keep it private. And here's the tree. And just like in building or just like pin questions into assignments, I just need to have the ID number of the question that I care about. So, for example, I could come in and take a question here. Let's say I took my question from the thermodynamics class or question, an assignment that I have right now, let's say equilibrium. And all I need is to take this thing and say, well, I copy the code, this number here, and paste it right there. And now I just drag it. And then if I have a different node, I'm able to add it and drag it over. If I want to create a completely new node, I press a new node, and then I can move it. And what I recommend to people is to build the empty structure that you have and say, okay, this is what I want. I want to have 3 branches dealing with certain each node. Okay. And now these are empty branches. That means there's no exposition, there's no question connected to it. It's just an empty box, except for the top one, which actually has a real question embedded into it. And then I can come in, and if I want to, I can actually edit the question or edit the node in here, or assign a new adapt entry into it and such. I'm going to leave it at this for now. This right here is the basic structure, is that you build the tree and then you start adding the nodes as you see fit, and you can come in and you can modify and tweak it off of there. It's pretty graphical in the way it's put together, and you can structure these things and say, well, look, I really feel I need 2 branches, but I'm going to put 2 expositions, and then I have a question at the end, or what we call a branch assessment down below. You can design it equally like that. Every time I rearrange it, it saves it, so I never lose it if computer crashes or something like that, and such. Or I could equally decide that I want it to be 4 as we move this way, or I could hide that. I'm going to leave it at that and let you guys play around with that. There will be some instructions that will be at the top here that I'm going to add to it early next week, so it's a little bit easier for you. If you have any questions or concerns, you can do a search on LibreTexts on learning trees, and you can get some more details behind that. I'm happy to go through any other questions even though I know is a little bridged at the end here. Otherwise, I can let you enjoy the rest of your fine Friday.